I ran the project once, and you got 85% confidence. Oh, 80% confidence.
It freaked me out, so I did it again.
Hold that thought. Hold that. So she did it a second time because the 80 freaked her out. I'm here to tell you the 80, it's okay to get freaked out if you're the 80. But the idea about 95%, what does 95% confidence mean? Who wants to succinctly state it for me? Succinctly state what it means to be 95% confident. Michael, go.
95% of the time, this confidence interval will catch the mean.
Whatever, oh, good, exactly. 95% of the time, overtime, I like that. But 95% of the time, and I'm going to imply that that means overtime. With repeated trials, you're going to miss it 5% of the time. Okay, so sometimes you're going to miss it more than 5% of the time, and sometimes they might get 100% confidence. Well, there we go! So what I'd like to do is real quick weighted average. Real quick weighted average. I want to average all your guys' results, because this is the best part of this assessment, is to look at the results when you're done, and then collect the results and see what the average comes out to be, and see how close we are to 95%. Because I set the interval up to be at 95%. In other words, what the critical values I used were designed to catch it 95% of the time. So let's take a look. Let's go into here. Don't need these anymore. So we did have an 80. Did anybody get below 80% confidence? I mean, theoretically speaking, if I do this job long enough, I'll see 0% confidence from one student at some point. That poor student, because they're going to freak out if that happens. That's like opening a bag of M&Ms and seeing all greens. I'm like, it's going to happen eventually. It has to happen. It has to happen eventually. 85, 90, 95, and 100. Okay, so we got 180, I'm assuming. We got the 180?
I got 80.
Oh, you got 82. 85. 85? No 85s. 90s. 90% confidence. These guys right here got 90s. 95, hit 95 perfectly. Fine, there we go. And we hit 100% confidence. 9. Okay. Highly skewed distribution. I love it. Highly skewed distribution. Let's take a quick look at that.
Are you talking about our project that we're turning in?
I am.
Okay, that's what I thought.
Yeah, just which confidence did you get? Right, looking back at the project. So here's the results. Highly skewed. Let's make the window a little bit more agreeable. Maybe go from 80 to 105. There she is with the box plot. We got an out. You guys are outliers, the 80s. It's okay. Every bell curve has outliers. Every bell curve has outliers. Then we're going to talk a lot about that today, because this whole idea of a p-value is tied right, as we saw over and over again last week. Is it an outlier, or does it belong somewhere else? Now this doesn't have a comparison. This is you were analyzing these baby weights, and you're trying to see where they fall. So let's just run a real quick one-bar stats. Maybe look at the average and the median, since it's so highly skewed. Maybe the median, because we have a small sample. Let's see what we got here. One-bar stats on L1 and L2. Well, there's your average. 95.3%. There's your median, 97.5, actually a little bit above 95. So, again, Ange, I love the point you brought up. She stood there, you look so nervous at the desk, you're like, I got 80, I got 80. It's okay, somebody else got 100. Actually more, I mean, for every 80 that was gotten, we saw 200s, if you think about it. So if you look at that in and of itself, for every 80 there's 200s, there's 95% right there, and it counteracts your 80%. And then you had a bunch of 95s, which were right where they should be. Does that make sense? I mean, it's all a balancing act. It's all averaging. And sometimes you have to look at averaging. I mean, this is the definition of 95% confidence. How many of you guys just kept holding the F9 button down and watching what happened with those?
On the chart, yeah.
Is it?
Okay, I feel better with my 100.
It's pretty good, because not every time. All I was asking you to do is to take one snapshot of 20. But then you hold that F9 button down, you're like, oh, there they go, there they go, there they go. I haven't gotten a chance to rewrite that one yet. I'd like to rewrite that one so that it keeps track of cumulative trials, so every time you press F9, 20 more go in, and just like we used to do back in 243, I just haven't rewritten this one yet. And then you'll see it close on 95%, just like in 243. When we had the die roll simulation, it closed on the pie chart of 1/6. Very quickly, actually, very, very quickly. And you can see it close right here with a whopping 18 trials. So it's going to close pretty quickly. But don't get worried. And Renee jokingly said something earlier which was awesome. She's like, but it's a problem. What did you say? Probably was a promise? Is that what you said? I think it was. It's a promise. Sure, as long as you redefine your word promise to be over time what you can expect with fluctuations. Then yes, it's a promise. But it's an average. As long as you can bridge that gap. And I know even after a term of 243 and half a term of 244, that's still a new idea. it's tricky to look in terms of averages. It's still tricky to look in terms of averages, and it's hard to look in terms of averages very often. Because we want things to apply to us. To us. How many times have I been told acupuncture doesn't work? Actually it does. Like, well, no study has ever been published. I'm like, I didn't claim a study ever has been published, but it's the only thing that takes my allergies away. Oh. And that's the difference between statistics and anecdote. But in this class, we're learning how to deal with the averages. We're learning how to deal with an entire population studied through a sample and what happens to that middle person or that middle thing or that middle item. Okay? As you go through life, you begin to realize which one's more important. Is it the anecdote or the statistic that's more important? Right now, we're only focusing on the statistics and that center. Because that's all we can do. I can't argue anecdote with you guys because it would be a very boring argument. I'm right. No, I'm right. We're both right. And then we go home. And then we're done. Not that this has to be an argument, but at least if we look at averages, there's mathematics to back the average up, and we can revert back to that. Stacy requested it today, so we'll get into that today, the mathematics behind the p-values. So, cool? Good. Now, I do have some stuff to give